Okay, first example for graphing a rational function. The things that we need to find: holes in the graph, x-intercept, y-intercept, horizontal asymptote, and vertical asymptote. Okay, so the first thing you want to do is you want to look to see if you can simplify this in any way. Look to see if there is a common factor in the numerator and the denominator. And in this case, we don't have anything that's similar in the numerator or denominator. So since we don't have a common factor, in this case, we're going to have no holes. For the x-intercept, remember the x-intercept is the value of x when y is 0. So if I plug in 0 for y and see what I get out for x, what's going to happen is we're not going to have any x-intercept either. Because remember, in order for that whole fraction to be 0, the top needs to be 0. And there is no way by plugging in a value of x that I could ever make that numerator equal to 0. That's just 1 up there. There's no way to change that. So it's impossible for us to ever plug in a value for x that I would get out 0 for y. Okay, the y-intercept is the value of y when x is 0. So I'm going to plug in 0 for x, and I'm going to get that the y-intercept is negative 1/3. And if I put that in as an ordered pair, that would be 0, negative 1/3. Okay, now the horizontal asymptote, we have to refer back to those 3 rules, and you will need to know those for the test. They will not be on your formula sheet. The 3 rules are looking to see if the degree of the top is equal to the degree of the bottom, or if the degree of the top is less than the degree of the bottom, or if the degree of the top is greater than the degree of the bottom. We need to compare those degrees. So in this case, the degree of the top is 0, and this is degree 1. So, because the bottom is bigger than the top, or I could say the top is smaller than the bottom, if you look at those 3 rules, you're going to find that a horizontal asymptote is going to be y is equal to 0. For the vertical asymptote, you want to look to see after simplification what values of x make the denominator 0. Because we didn't have to simplify this one, I can just go ahead and look at that function and say, okay, what would I plug in for x so that the denominator would be equal to 0? And that would be x equals 3. When you write out your horizontal and vertical asymptote, these are actually lines that we're going to draw on the graph. So you want to make sure you list it as an equation. Don't just write down horizontal asymptote is 0 or vertical asymptote is 3. You want to actually write it as an equation. Okay, so let's put this all together and graph it. Because there's no unusually large numbers here that we have to graph, I'm just going to make this a scale of 1 on both the y and the x-axis. So when I go through, I don't have any holes to draw. I don't have any x-intercepts to draw. I do have a y-intercept to draw at negative 1/3. So somewhere right about here, I know the function is going to pass through that point. I do have a horizontal asymptote at y equals 0. That's the x-axis. So I know that's where my graph is going to long-term flatten out. So one thing that you need to know about asymptotes is you can pass over a horizontal asymptote, but you can never, ever, ever cross over a vertical asymptote. Okay, we have a vertical asymptote at 3. So here's my vertical asymptote. Here's my horizontal asymptote. Now, in order to see where the function is going up and down, or by my vertical asymptote here, what we're going to do is we're going to actually graph this on your calculator. And when you put this in your y equals, make sure you put parentheses around the denominator. So when you put it in, you're going to put it in like this, 1 divided by, and then in parentheses, x minus 3. If you don't put those parentheses down there, the calculator is going to think that you're doing 1 divided by x only, where only x is in the denominator, and then you're going to subtract 3 from it. So you have to put those parentheses around the denominator so you let the calculator know that the x and the minus 3 is in the denominator. Okay, once you put that into your y equals, you can hit zoom 6 for zoom standard. And the zoom standard is your standard viewing window. So on both axes, it goes from minus 10 to 10 with a scale of 1. So when you do that, what you're going to find is your graph is going to look like this. I didn't leave myself enough room on the other side, I guess, but you can look at it on your graph on your calculator. So on the left side of my vertical asymptote at x equals 3, it's going down to negative infinity. And on the right side of my vertical asymptote, that's going up to positive infinity. Now we have some new notation to learn here for end behavior. We talked about end behavior before with arrow notation, where we said as x goes to positive or minus infinity, y goes to positive or minus infinity. Now we're going to actually add in a little bit more to that arrow notation. If I wanted to explain what this arrow means right here in green that I just circled, what I would do is I would say as x approaches 3, but I would say as x approaches 3 on the right-hand side, and to indicate that we're coming from the right-hand side, where I normally would have an exponent, I'm going to put a little plus sign there. So if I trace my graph, if I'm coming closer to x equals 3 from the right-hand side, I would put a 3 plus. Now when x comes in from the right of 3, look where that arrow is going. That arrow is going up. So I would say y goes to positive infinity. So there's my arrow notation for that first arrow. Now if I look at this arrow here, I would say as x approaches 3 now from the left, so I would put a little negative sign up there where I normally would have exponents. So as I trace that graph coming in from the left, look what that arrow is doing. That arrow is going down. So I would say y goes to minus infinity. So a little bit of new notation there. Now for this arrow here, I would write as y, oh sorry, let me erase that. As x approaches minus infinity, because this arrow here, the x is going to minus infinity, look where the arrow is heading towards y. It's getting closer and closer to y is equal to 0. And then for this arrow over here that kind of, whoops, that goes off the page, let me go back up and fix that. For this arrow here that goes off the page a little bit, I would say as x goes to positive infinity, y is also approaching 0 because it's getting closer and closer and closer to the y-axis.